Internet, welcome back. Today we're going to go ahead and discuss lesson 4.3 notes, proving lines parallel day 2. For the notes today, we are going to be dealing with the two-column proofs, just like the lesson 3.3 notes, algebra properties and proofs. So we're going to be dealing with those two-column proofs, okay? So number one, given line L is parallel to line M, my goal here is to prove that angle 2 is congruent to angle 7. And this is the proof for the alternate exterior angles theorem. So that means that we cannot use alternate exterior angles in our proof or for our reasons because we are trying to prove that. But what we can use is literally everything here except this, okay? We can use this. Those are proven. But we cannot use this because that's what we are trying to show, what we're trying to prove, okay? So let's go back to the proof. Again, given line L is parallel to line M. So this is what we can assume. This is what we can assume. So here is line L and line M. And I'm going to go ahead and draw these feathers because those lines are indeed parallel. And again, you know, how I like to approach proofs, I told you this before, I don't like to look at this. I like to look at this, what I'm trying to prove, in this image right here. So this is my game plan process. I'm trying to think, okay, what am I supposed to do? Again, I know that line L is parallel to line M. And I can see that angle 2 is right here and angle 7 right here. I need to show that these two angles are congruent. So how am I supposed to do this? Well, okay, well, I know that angle 2 is congruent to angle 6, okay? I just know that angle 2 is congruent to angle 6 because, look, this is what I'm going to do. Since angle 2 is congruent to angle 6, and that's because of the corresponding angles postulate, right? That's because of the corresponding angles postulate. Notice this. The fact that 7's here and 6 is right here, and there's these lines that intersect and they form, you know, a beautiful looking X. Well, the angles across from each other are congruent. Okay, so that means that I can draw an arc here, and I can draw an arc here, and I can draw an arc here as well. One arc there, though. And the reason why I'm putting one arc instead of two arcs is because angle 7... or I should say angle 6 is congruent to angle 7 by the vertical angles theorem. Right? So if angle 2 is congruent to angle 6 and angle 6 is congruent to angle 7, y'all, by logic, angle 2 is congruent to angle 7 by the transitive property. Okay? So I really think I have I think this is what I'm supposed to do for my proof. So let's go ahead and take a look at the two column proofs. Number one, the statement, line L is parallel to line M, and that's just, it's right here, right? It's stated given. We're just going to write given for a reason. So this is given. And then angle 2 is congruent to angle 6, right? So just by looking at angle 2 is congruent to angle 6, if I'm comparing one region to another region, that's just corresponding, right? Just like I said before, they are congruent because of the corresponding angles postulate. So that's what I'm going to write. Corresponding angles postulate. Okay? Now, for 3, I can see that angle 6 is congruent to angle 7. And I already figured that out. 6 and 7, they are congruent because of the vertical angles theorem. Vertical angles theorem. Okay? I don't know what else to tell you. This is already explained. I already figured out what I'm supposed to do before I approach the two column proofs, right? Vertical angles theorem. We already see it. And then, logically, angle 2 is congruent to angle 6, and angle 6 is congruent to angle 7. That means that angle 2 is congruent to angle 7. That's because of the transitive property. And then if this was not written out, you will take the prove and put it right there for your statement. Okay, you will copy and paste it there. Anyways, that's it. That's me proving that angle 2 is congruent to angle 7. I just proved that the alternate exterior. I just proved the alternate exterior angles theorem. So I will end the proof right there with my QED or square. Okay. Alrighty, onwards to number 2. Given that M is parallel to N, prove that the angle 3 and angle 8 are supplementary. Okay, so let's go ahead and take a look at what's given. M is parallel to N. That's what we can assume. This is what we can assume. So I have these two lines that are parallel to each other. So I'm going to draw these arrows to show that they are parallel, and it's cut by a transversal L. Okay, so what do I really need to prove? I need to prove that angle 3 and angle 8 are supplementary. So, just, you know, since we're dealing with this unit, we really need to refer back to our pink sheets and such because, well, look at the fact that, my goal here is to prove that the angle 3 and angle 8 are supplementary, and the only theorem that I know that deals with supplementary is the same side interior angles theorem. Okay? So, supplementary, same side interior angles theorem. So, let's go ahead and take a look at where 3 and 8 are. So, 3 is right here. It's inside of the parallel lines, and then here's 8. It's outside of the parallel lines, right? It's an exterior angle. So if I look very, very closely at my, you know, the image right here, if I can try to figure out what's on the same side, then I think I have an idea on how to approach the proof. So what do I see? I see 3 is on this side of the transversals. On the right side of the transversal, what else is on the right side of the transversal? 6, right? So 3 and 6, let's write that down. Angles 3 and angle 6 are same side interior angles, okay? And again, you know, my goal here is to prove that angle 3 and angle 8 are supplementary. And this is great because, look, 6 is right here, 8 is right there, and they are basically congruent, right? They are basically congruent by what? The vertical angles theorem. So I can write, you know, angle 6 is congruent to angle 8 by the vertical angles theorem. And we can see that since we can see that angle 8 is angle 6, right? Then I know for sure that by the same side interior angles theorem that angle 3 and angle 8 are supplementary because of the same side interior angles. Has to be. So this here has to be angle 8. Angle 3 and angle 8 are same side interior angles. So I think I have an idea on how to approach the proof. Let's go ahead and jump right into it. So given that M is parallel to N, right? It's right here. This is just copy and paste it there. And the reason for that would be just given. Has to be given. And angle 3 and angle 6 are supplementary, right? So angle 3 and angle 6 are supplementary. And that's because, I should write supplementary right here. They are supplemented by the same side interior angles. And we can just go back to our pink sheets and take a look what the same side interior angle says. It says if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. That means you're just adding up to 180 degrees. So in this case, angle 5 and angle 6 are supplementary, right? That's the example on the pink sheet. And here, angle 3 and angle 6 are supplementary, and we just write same side interior angles. Okay, And then just by looking at, I'm going from here to here, it says definition of supplementary angles, okay? So that's just basically going from, okay, we know that angle 3 and angle 6 are supplementary. That's geometry stuff. I need to make it into an algebraic equation. It's not going to be definition of congruence. I just want to point that out. I'm just going from here to here. That's just basically saying, okay, it's measure angle 3 plus measure angle 6, and supplementary is equal to 180. That's by definition of supplementary angles, okay? That's definition of supplementary angles. Now, number 4 says angle 6 is congruent to angle 8. And y'all, we did already establish that 6 and 8 are congruent because of vertical angles. So I write vertical angles right there. And now I'm going to convert it because it says definition of congruence. I say measure angle 6 is equal to measure angle 8. And that's definition of congruence. Because remember, this stuff right here is geometry. And now you want to get that into algebra. Okay? Definition of congruence. Now what? Measure angle 3 plus measure angle 3 plus measure angle 8 is equal to 180. Okay, so remember what I said. Measure angle 3 plus measure angle 6 is equal to 180, right? Measure angle 3, measure angle 3, measure angle 6 now became measure angle 8. Why? Because measure angle 6 is equal to measure angle 8, and the 180 stays the same. So what really happened to the measure angle 6? Well, it got replaced by the measure angle 8. So that's me using substitution. That's me using substitution. Okay? And then I can write the prove angle 3 and angle 8 are supplementary. Yes, measure angle 3 plus measure angle 8 is equal to 180. They're supplementary, and that's because of the definition of supplementary angles. Definition of supplementary angles. Okay. Alrighty, number 3. Copy and complete the proof of theorem 3.5. Don't know what that is, but we don't really need to copy and do anything else except prove this, supposedly a theorem. So, given that angle 1 is congruent to angle 2, prove that L is parallel to M. Ooh, okay, so again, this is what we can assume, and then since we're trying to prove lines being parallel, that means I have to use the converse theorem. So, need to use the converse theorems here. So, angle 1 is congruent to angle 2. I can assume that. Let's go ahead and mark that in our picture. So, angle 1 is congruent to angle 2. And angle 1 congruent to angle 2, that's basically because I've already given. And so if I use my converse theorems here, then that means that I can show whatever the case is, then I can show that the lines are parallel. All right. So let me go ahead and find the notes again. It's over here. Okay, so what do I know? Angle 1, angle 2 are congruent. Okay? I cannot say, well, actually, I can say that angle 1 and angle 2 are congruent, and that's because of it's given. And I think what we're trying to do here, I think the reason why this proof exists is because we're trying to prove the alternate exterior angles converse, I think. But I know for sure, I'm just going to go ahead and not use the alternate exterior angles converse, because that is what we're trying to prove. And here's 2, here's 3. They're definitely congruent. I'm going to put one arc, though, because of vertical angle. So angle 2 is congruent to angle 3 by vertical angles. And we can see that angle 1 is congruent to angle 3. Right, angle 1 is congruent to angle 3, because look, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. Logically, that states that they are congruent by the transitive property. And then we can say that lines L is parallel to line M, because look, 1 and 3 are congruent, right? And if 1 and 3 are congruent and they are basically corresponding, they are relative to each other. If I compare one region to the other, if you're standing at 1, you're basically standing at 3. Look at this. We can take a look at the corresponding angles converse. It says if two lines are cut by transversal and the corresponding angles are congruent. Yes, 1 and 3 over here, I think was 1 and 3, right? Yeah, 1 and 3 over here are congruent. Then the lines are parallel. So 1 is associated to L and 3 is associated to M. So they are parallel by the corresponding angles converse. Okay, so let's go ahead and start writing stuff down. Angle 1 is congruent to angle 2. That's a given. We already know. Angle 2 is congruent to angle 3. And if we look, okay, well, 2 and 3 are congruent because of the vertical angles theorem. Has to be vertical angles. And then angle 1 is congruent to angle 3 because, look, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3. So logically, it's the transitive property. And then we say that line L is parallel to line M because of the corresponding angles converse. So whenever you have, like, this is the rule of thumb. When you're proving lines are parallel, your reason should be one of the converse theorems, okay? So whenever you are proving lines parallel, then the last reason should be a converse theorem. It should be a converse theorem, okay? So that's the proof for number 3. I think this was trying to prove the alternate exterior angles converse, if I'm not mistaken. But I don't think that really matters. But yeah, that's how you approach the proof. Alrighty, let's go ahead and take a look at number 4. Given that angle 1 and angle 6 are supplementary, prove that K is parallel to I. Okay, so I know for sure that 1 and 6 are supplementary. And remember, supplementary means 180 degrees. Or to be exact, that you add up to 180 degrees, okay? And I'm going to go ahead and prove that line K is parallel to line I. And I can't assume that they are parallel until I get to it. I have to use, one of the converse theorems, right? You're going to have to use one of the converse theorems to prove that the lines are indeed parallel. So make sure that you're referencing this page, because that's going to help you answer some of these questions over here, or fill in the blanks over here. Okay, so again, 1 and 6 are supplementary, right? Angles 1 and 6 are supplementary because that's what we can assume. That's what we are given, and it's perfect to keep note of that. Also, just by looking at the picture here, I can see that 1 and 4, right? If we look at that, 1 and 4, that's also supplementary, right? Since I'm dealing with 1, I want to make sure that 1 is dealing with something else, right? 1 is supplementary to 6, and 1 is also supplementary to 4, and that's because, so angle 1 and angle 4 are supplementary by, well, that's going to be the linear pair theorem, okay? And since, if I want to talk about algebra stuff, I can say that measure angle 1 plus measure angle 6 is equal to 180, and that's me using the definition of supplementary angles. And we know that's basically measure angle 1 plus measure angle 4 is equal to 180. I think I have an idea, okay? But you're not going to believe me. But let's go ahead and just take a look at the proof so you can believe me afterwards, maybe. Angle 1 and angle 6 are supplementary. That's going to be a given. And angle 1 and angle 4 are also supplementary. And that's because we stated that we can see that 1 and 4, they are supplementary because of the linear pair theorem. So I'm going to write linear pair theorem. Okay? And what's the result of that? Well, angle 1 and angle 4 are supplementary. Angle 1 and angle 6 are supplementary. This is just all, geometry words. Let's get that into algebra stuff because that's what it says for a reason. Definition of supplementary angles, where I'm going to basically convert this into this. Right? And then this now becomes that. Okay? And if measure angle 1 plus measure angle 6 is equal to 180, and measure angle 1 and measure angle 4 is equal to 180, let me go ahead and rewrite that so it looks like this. Something more familiar. Right? So I have A equals B, B is equal to C. That means that this is equal to this. That's because of the transitive property. Transitive property. And then, oh, look at it. This is like an algebraic equation where measure angle 1 plus measure angle 6 is equal to measure angle 1 plus measure angle 4. What do these expressions have in common? Well, they have measure angle 1 in common, so I can just basically subtract both sides by measure angle 1. So this is going to give me measure angle 6, measure angle 4. That's because of the subtraction property of equality. Okay? Don't forget that one. And then, what else do we have to say? This is currently in the language of algebra. I want to get this in the language of geometry. That's definition of congruence. So we can say that angle 6 is congruent to angle 4. Now, if these two angles are congruent, right, and they are alternate, they are opposite sides of the transversal, and they're both on the inside, that means that we're using the alternate interior angles converse to prove that the lines are parallel. And again, I want to emphasize that the converse theorems, they prove lines parallel. They prove lines parallel, okay? Alrighty, last question for today. Given that the segment BE bisects angle DBA, angle 1 is congruent to angle 3, go ahead and prove that segment CD is parallel to segment BE. Okay, so I need to prove that these lines are parallel. We can't assume that they're parallel until we use one of the converse theorems. So we're definitely going to have to use one of the converse theorems to prove that these segments are indeed parallel. Always look at the given. What is it telling you to do? It says that segment BE bisects angle DBA and angle 1 is congruent to angle 3. Let's go ahead and mark this stuff first. Angle 1 is congruent to angle 3. Okay, angle 1 is congruent to angle 3 because we can assume so. And know that segment BE, right? So here is, this is BE, segment BE. It bisects angle DBA. Okay? What is the result of having that bisector there? Okay? What is the result of having that bisector? What does a bisector do to an angle? Well, remember, with a bisector, it splits the angle into two congruent parts. So here is the angle DBA, and this is the bisector. What is this bisector doing to this angle here? Well, it's going to split this angle into two congruent parts. So angle 3 is congruent to angle 2. And I'm going to put only one arc there because if angle 1 is congruent to angle 3, and we know that angle 3 is congruent to angle 2, y'all, we're just going to have to use one arc, okay? Because that makes logical sense. If we say that, oh, angle 2 deserves 2 arcs, but this is only angle 1, that doesn't make sense because these two angles are congruent. So that's going to be very, very helpful. Let's go ahead and write what we just wrote. So the result of having that bisector is because angle 2, or the result of having that bisector is angle 2 is congruent to angle 3. Definition of bisector right there, okay? All right, so if I can, let's just go ahead and jump into the proof. Segment BE bisects angle DBA. Angle 1 is congruent to angle 3. Y'all, that's just a given right there. Has to be. And then segment BE bisects angle DBA. By definition of angle bisector, angle 2 is congruent to angle 3. Or maybe I should say angle 3 is congruent to angle 2. Because look at this. 1 is congruent to 3. 3 is congruent to 2. Therefore, 1 is congruent to 2 by the transitive property. So then mark, or we already did mark, and you can see that this is already marked, but I'm going to go ahead and just put this in red. Angle 1 and angle 2 are congruent. And if I were to just extend the lines here, let's use a different color. If I extend the lines here, y'all. Okay, this is basically two lines here, cut by this transversal. And 1 and 2 are alternate. They are congruent. And they are in the inside of these lines. They're inside of the line. So this has to be, we have to say that segment CD is parallel to segment BE by the alternate interior angles converse. Okay? Again, when you're proving lines parallel, in this case, you gotta use the converse theorems. You gotta use the converse theorems. I'll see you next time.